All right, guys, go ahead and get up your notes. We're going to pick up where we left off yesterday. And if you recall, yesterday we talked about the 5 major areas or specialized areas of earth science being astronomy, meteorology, oceanography, geology, and environmental science. So if you missed any of the definitions yesterday, you can certainly pause as you go through and fill those back in. There you go. So there's your geology, oceanography, and environmental science. Again, the overview chart that you guys had to fill in. So astronomy, meteorology, geology, oceanography, and environmental science. I feel like I'm saying the same thing over and over again, but hopefully this pays off. And then we started to talk about the importance of earth science, and really we want to highlight in these things, and I literally mean grab your highlighter, right? The discoveries that have been applied to society's needs and problems, right? We talked about Vesuvius and our warning systems for earthquakes, being able to track hurricanes and see where vulnerable areas for flooding might be, right? These are all different applications of technology. Then application of scientific discovery is what we'd refer to as technology. And I mentioned our idea of technology today is the latest iPhone or iPad or fiber optic versus coax wiring. But anytime there's been an advance in application, we've seen technology. So at one point in time, the wheel was technology, right? We take that for granted. There are wheels all over the place. Think back to the early caveman. Fire was technology. Somebody figured out how to make fire, and that meant that we could cook and we could change things. In some of my classes, I was talking about the fact that using technology, we've learned how to train animals to be our companions, and so we have domesticated dogs and cats and whatever else people have climbing around their house. But even down here, you see the smoke detector, right? Rather than laying in your bed and waiting till the whole house is on fire and engulfed in smoke and flames, we have detectors that early on will find that smoke and give you the information for you to be able to exit your family, things like that. So these are all different applications for technology. And in the same way, earth science uses technology. Think about GPS, right? We all use it to get from location to location, but they can actually use that to monitor sea level. They can use that to see changes in terrain, see swelling in a volcano, all kinds of fun stuff. So thinking along those lines, earth science to use maps, computer satellites, that's what I was referencing there. But we've also improved farming methods, right? Being able to control when we water. I mean, think farming, but then think about your own sprinkler system at home, right? Sprinkler systems now can link up to your phone and go out onto the internet, track the weather forecast, and decide whether or not to water or not to water. That's a huge savings of a resource that we need, right? Potable fresh water, limited supply. The way that they churn soil and grow crops, all of these different things are coming back to technology and ultimately improving the quality of life for all of us. So I started to get into the idea that Earth and studying earth science requires us to see the interconnection between different aspects of our planet, mainly the atmosphere, the solid earth, the water, the oceans, and then life. And for that, we have specific names. So we have the geosphere, which would be the solid earth. And you're seeing in this diagram that you have the different layers of the earth. The standard crust, mantle, outer core, inner core. A little spoiler alert, We'll get into some other subdivisions in that a little bit later this year. Then we come up on the atmosphere. And the atmosphere, defined as the blanket of gas that surrounds the Earth, or the envelope of gas that surrounds the Earth, is where we're going to find weather. That's where we're going to find all the gases like oxygen and nitrogen and carbon dioxide. That's also where we're going to find the ozone layer, where we'll see meteor showers. And yesterday we talked about meteorology being the study of the atmosphere. So the interaction now of the atmosphere with the geosphere is where we see weather, precipitation, whether it's snow, rain, hail, then coming and bombarding the solid rock, changing that. So that's going to be a concept that we look at this year. The hydrosphere being all the water on Earth. And you'll see the distinction down here. Cryosphere is the frozen water, so that's when we're getting into glaciers. But the general water, hydro, and then sphere would be the aspect of the Earth that's going to incorporate that. And then lastly is you got the biosphere, and that's all the living organisms. That's you and me, and everything that supports us. Right? So when we talk about all the microorganisms, the plants, the decomposing matter, all of that coming together, that makes up the biosphere. So that's what we refer to as Earth's four spheres, and the interconnection makes up Earth's systems or Earth system science. And this brings up the idea that all of Earth systems are interdependent, meaning that they're all connected. All right, so what I was just describing with precipitation, you see over here in this diagram, right, is you got the precipitation coming down over here. Over here you have the hydrosphere sending gas because of evaporation into the atmosphere. Right? That's making part of what we'd refer to as the hydrologic cycle. But then some of that precipitation over here is infiltrating into the ground. That's where we get groundwater, infiltrating, soaking into the geosphere. So all of them connected. All of them constantly affecting one another. That's this idea of Earth's system. All right, so the second part of this lesson is understanding maps. And if you've ever been to a theme park, you've certainly used a map because that's how you found your way from one ride to the next, or maybe that's how you found the restroom. So this brings up a great focus question. How do we use maps to describe Earth? Right? So in a theme park, we can describe the locations of rides. Here, how do we describe the Earth? So the first step would be to think about latitude, longitude, which hopefully you've heard about in grade school, where we say, oh, well, we have so many degrees north, so many degrees west or east. Then we can also talk about elevation. And this is where we're going to talk about contour lines and looking at topographic maps so you can actually see the change in elevation. Might be kind of useful if, say, you're thinking about buying a property somewhere else in the world and you haven't actually gotten there. Getting a topographic map for the area can tell you a lot about the terrain. Obviously, I would want to buy higher elevation over low-lying or below sea level elevations, because then you got to start worrying about things like flooding. So again, taking a look at all of this from a useful how earth science interacts with our lives. So here you got some new vocabulary. When we talk about cartography, that's map making. Cartographer is the one that makes the map. The equator, that's that nifty line that separates the northern and southern hemisphere, right? Then you have latitude and longitude. Latitude are lines that run east and west and are going to be labeled north and south of the equator. And then longitude would be lines that run north-south but are labeled east and west of the prime meridian. So all of those kind of go in a set, and you'll see how a lot of these terms play out in the following slides. So I just alluded to the idea that maps are two-dimensional representations of three-dimensional objects or surface. And the science of making maps is cartography. So you might want to write in parenthesis after that, cartographer is the person that actually makes the map. And then we said the equator is the imaginary horizontal line, right? That's going to separate the northern and southern hemispheres. So then latitude are the parallel lines parallel to the equator that are going to be labeled north and south. And just make a little note that you can have 90 degrees north and 90 degrees south. 90 degrees north and 90 degrees south, which can give us a total of 90 degrees north plus 90 degrees south. It's going to give us a sum. You can have 180 degrees of latitude. Cool. So here you can see how those lines work. You see the 90 north, 90 south, and how they're parallel to the equator. Longitude, on the other hand, are going to intersect at the poles, so they're lines that run north and south. Again, imaginary lines. The first one being the prime meridian, right, or the 0 degrees of longitude. And they're going to connect at the poles, so they're semicircles. They intersect at the poles, right? So that's a difference if you want to contrast latitude, longitude. Latitude lines are parallel to one another, whereas longitude lines are half circles that intersect at the poles. And here you can see the latitude lines all intersecting at the poles, and you can see this half sphere, and then labeling it east or west of the prime meridian. Right, the opposite side of the Earth, by the way, the 180th meridian, would be the international date line. That's one of the vocab words that you saw. So that wraps up our lesson for today. I know I moved pretty quick, but if you need to go back and fill in any notes, by all means, please do so. Tomorrow's lesson is actually just going to be a straight video. It's going to be an ed puzzle, so you guys will have to answer, I think it's 5 questions in the ed puzzle. But again, important lesson because it's going to shape our discussions and really clue you guys in on how I see God's role in earth science. So be keen to that tomorrow. Right now, go ahead and knock out the vocab because that's going to be your homework for tonight. So you got the vocab sheet. You guys are going to start working on that.